Models are used in science to help explain and clarify how some aspects of nature behaves. They do not necessarily provide a full representation of nature. They can never provide a better explanation than what nature provides. They just simplify the complex features of nature. They provide just a glimpse on just one or a few aspects of nature behave. Okay, now we talk of four different types of models here. A physical model is a built-up model. It means it is something that you can touch, you can manipulate. For example, think of the solar system models that we buy to decorate kids' rooms, or a model of the Earth. These are physical models. Now, conceptual models are mental pictures that we have in our own heads, in our own brains, of natural phenomena, to describe natural phenomena. For example, comparing how electrons move in an atom to the motion of planets in a solar system would be a conceptual model. Whenever you say that, you visualize the electrons going around the nucleus like the planets going around the sun. Electrons do not move exactly like that in nature. They do not move exactly like that around the nucleus. But that gives us a simple model to help explain some of the properties of the atom. Mathematical models are models that use mathematical tools like equations, graphs, tables. It is based on variables and equations. For example, writing Newton's second law of motion as net force is equal mass times acceleration, that's a mathematical model. Writing Newton's law of gravity as a constant times the product of the masses over the distance separating them squared, that's also a mathematical model. Having a graphic explaining a behavior in nature is also a mathematical model. Now, computational models are models where we cannot do the calculations by hand like the mathematical model. We take advantage of computational power. So this is where we make lots of calculations using computers to help explain natural behavior. Computational models are used quite a bit for weather predictions, for example, to explain how different weather fronts are moving and how are they going to interact. We often rely on computational models for that.